This video, we are going to see tree data structure. Under this, we will see what is tree. Then we'll see what is the use of tree, or why to use tree, or where to use tree. Then we will see the types of trees, and at the last we will see how to represent the tree, how to store the tree in the computers. So let's see first of all what is tree. Tree is nothing but the hierarchical data structure. Means what? Here we can maintain the hierarchy. Hierarchy means what? If you are having, if the grandparent, see here I have given one example that A is a grandparent. A is having the two childs B and C. Again B is having the two childs E and F, and C is having the child W and H. And again V is a child of W. So this type of information, if you want to store in the memory, so in that case, we can go for the tree data structure. It is a hierarchy. Same way we are having in the college also, we are having the director or principal. Under that, we are having the HOD. Under the HOD, we are having the coordinators. And under the coordinators, we are having the mentors. And under the mentors, you are having the faculties or students. So this type of hierarchy we can maintain in this tree data structure. So this is not linear data structure. Non-linear means what? You are not going to store the elements one after another. So it is maintained or it is stored in a hierarchical way. And the nodes are connected with each other, and that connection is called as edges. So what are the factors to be considered by choosing the data structures? So why to use tree? That is the answer. So for that, first of all, we need to check, we need to find out what type of data we are going to store. If you are storing only the simple data which is not having any relation, in that case, we can go for the linear data structure. We can go for the array. If you want to store the information which has some relation, which have some hierarchy, in that way case, we can go for the tree data structure. If we are having the data structure in which we all the nodes are connected with each other and they are having some relation, they are having some cost in between, in that case we can go for the graph. So that type of thing, first of all we need to identify what type of data you are going to store, and according to that we are going to select the data structure. And how we are going to retrieve that data, that is also very important. If you are retrieving the data first come first serve, for that we can go for the queue. Next is cost of operations. If we are cost of operation means what type of operations you are going to perform on that particular data structure. If we are only searching the element and we are storing the element and insertion is not so frequent, in that case we can go for the array. This I am giving one example. But if you are having one list in that insertion is very frequent and in between you need to insert again and again, or delete, you want to delete in between again and again, in that case array is not the proper data structure for this type of operations. In that case we are going for the linked list. We need to check the cost of operation. So how much time required to delete the some element from the particular data structure. According to that, we are going to select the data structure. So here we are going to see the types of trees. So general tree, there are binary tree, then binary search tree, AVL, Anelson, Wilesky, Lancy tree, red and black tree, segment tree, and the last Fenwick tree. So these binary search tree, AVL tree, red black tree, segment tree, Fenwick tree, these all are nothing but the binary trees, but having some important properties, having their own different properties, depends upon its applications. So let's see one by one all these trees. First of all, general tree. So general tree is nothing but in that there is no any limit on the children's. Here we are having a as one root. A is called as root. Root is nothing but the node which is at the big top. And A is having three childs, or A is having three, what you can say, the nodes which is under that. That is B, F, J. Now, in this case, it may be two nodes, it may be three nodes, it may be four nodes, it may be five nodes. It is at no any limit. So, therefore, it is called a general tree. There is no any restrictions on the childs. So, under the B, we are having C, three childrens. Under F, again, we are having two childrens. Under J, we are having four childrens. And under M, we are again having two childrens. So, this is the general tree. So, no any restrictions, only we are having the hierarchy on the children's. Yes, this is the important topic, that is binary tree. So in the binary tree, there is only one node is having two children's or one children or zero children's. Means maximum you can have two children's and minimum you can have zero children's. If you are following this type of property, then that tree we can call as a binary tree. Binary means two, maximum two children's, minimum zero children's. So here we are having 8 having two children's, 3 and 10. 10 is having only one children, that is 14, and 14 is having one children, that is 13. 6 is having two children's, 4 and 7. And 3 is having two children, 1 and 6. So this is maximum you are having the two children's, minimum you are having the zero children's, and you can have one children also. So this is called as binary tree. How we can represent this binary tree? So you can represent this binary tree by the two methods. One, you can use the array, or second, you can use the linked list. In the array also you can able to store the binary tree. So this is, I have given an example, that is, suppose this is a binary tree. In that one, under that you are having 2, 3. Under 2 you are having 4, 5. Under 5 you are having 8, 9. Under 3 you are having 6, 7. Now if I want to store this type of information in the memory using array, so I can go for the array like this. So I am starting from the index 1. So first I am storing 1, that is 1. After that I am storing 2 and 3, that is 2 childrens of 1, that is 2 and 3. After that I am storing the childrens of 2, that is 4, 5, that is 4, 5. Then I am storing the childrens of 3, that is 6, 7, so 6 sevens. So I am going breadthwise, means first of all I am storing 1, then I am storing 2, 3, then I am storing 4, 5, 6, then 8, 9, like this. Now see here. But from this, if I want to, did I maintain the relations? Yes, we have maintained the relation. How I can get the values? How I can find out if the restore in this way? The child of, or the parent of 4, or child of 4, how I can get it? So that is the formula called as, the formula is 2n, 2n plus 1. 2n is the first child, 2n plus 1 is the second child. For example, suppose I want to find out the children of 5. So 5. So for the 5, here 5 is stored. So what is the children of 5? That is 2n. That is 5 into 2. That is 10. So this is 10th. Then the second child is 2n plus 1. That is 5 into 2. That is 10 plus 1, 11. So 8 and 9 is the children of this particular tree. So in this way you can find out the sequential, under the sequential, how we can get the children's. Linked list can be represented by, binary tree is represented by the linked list. So here I am having the node, under that you can have the left node, you can have the right node. in the left node you are having storing the address of this node, and in the right we are storing the address of C. Again from the B, if you are having one child, so under the left side I am storing the node, and at the right side there is no any child, so I am storing here null. Same way in the C also. In the left I am storing E, which is not having any left and right, and in the C, F, again the child of, that is side, this is child of C, and again no left, no right, so null, null. So this is also one type of representation of binary tree. So these are the some nomenclature we should know whenever you are using the binary tree. So A is called as root of the tree. Sub B is a sibling. C is a sibling. B and C both are siblings. This is the connector which is connects two node is called as edge. The last node which is not having any root or any nodes, that is called as leaf node. Here G is a leaf node, H is the leaf node, F is a leaf node, and D is also leaf node. It is also called as child node. B is called as parent node. So this is whole is called as a tree, and this is also we can call as a subtree of this particular whole tree. So in this, so you these are the some new this is some information we should know whenever you are dealing with the trees. Root, that is the topmost node. Leaf, which is at the last. These nodes are also called as internal nodes. Internal nodes means what? They are either they may be the child or they may be the parents. Level of the nodes. So here we can see the level. So this is level 0, this is level 1, this is level 2, and this is level 3. The internal nodes have at least one child. So these are the internal nodes. B is an internal, C is an internal node. G is not the internal node because it's a leaf. E is an internal node. A is a root. So root is always at the level 1. So these are the some properties of the binary tree. The height of the node defines the longest path from the node to a leaf. So what is the height of the tree? So here the height of tree is what? 1, 2, 3. The height of this tree is 3. That is 1, 2, 3. Height of this tree. So what is the height of this tree? 1, 2, 3. The height of this tree is 3. That is 1, 2, and this is 3. Longest path. So this is also one height. 1, 2. But longest. So that is longest is this one. A to C, C to G, and G to K. So this is what the height of the tree. That is 3. The maximum number of nodes at height 3 is equal to 1, 2, plus 1, plus 2, plus 4, plus 8. If height is 3, means how many nodes you can have in that particular binary tree. So that is nothing but the 15. See, this is the height of this tree is 3. So how many nodes are there? 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The maximum you can have the 15 nodes. So the formula is 2 raised to h plus 1 minus 1. Using this, we can get it how many maximum nodes you can have in that particular tree which is having the height h. The minimum number of nodes possible at the height h is h plus 1. So that is the minimum nodes. This is the maximum. So using these two formulas, we can get, if we are knowing the height, we can get maximum number of nodes and minimum number of nodes in that particular binary tree. Minimum height can be computed. So if you are knowing the nodes, we can find out the minimum height and maximum height also. So minimum height, we are having the formula h is equal to log 2 log to the base 2 n plus 1 minus 1. You can use this formula, find out the height of the tree if the n is given. You can find out the maximum height using h is equal to n minus 1. Using this is n is nothing but the number of nodes minus 1. This is using this, you can get it the maximum height of the tree. This is maximum possible height. This is minimum possible height. Depth of the tree. Depth of the tree is nothing but we just count how many edges between the targeting node and the root and ignoring the directions. So depth of G is nothing but 1 and 2. Depth of B is 1. Depth of C is 1. So that is what the thing. So depth of G is 2. That is 1 and 2. Here we are not calculating the height. Here we are only calculating how much edges you are having between the root and that particular node. If I want to find out the depth of K, so 1, 2, 3, like this. Thank you. Thank you very much. In the next video, we are going to see the binary trees.